For the first example, we will build an inclinometer application starting from the two examples for the accelerometer calibration and the sensor fusion that are available inside the S-Cube ISPU package. And then I will show you how to use AlgoBuilder and Uniqlo in order to visualize the results with a nice 3D model. Okay, let's get started with the inclinometer. The first step is to download the S-Cube ISPU package, and as you can see here, I already downloaded it. So if you go inside and we go into the ISPU folder, here first of all you can see you have a README file, and here you can find all the instructions needed in order to set up the ISPU toolchain, either for the command line usage or for an Eclipse-based IDE, where you need to install the plugins. For the purpose of this hands-on, I chose to use the STM330Cube IDE, where I have already configured the toolchain to develop for the ISPU. Then, if we go back to the S-Cube ISPU package, we can enter the device folder, and here you can find template, plus a number of examples. For the inclinometer, we need the accelerometer calibration and the sensor fusion 6-axis. We do not need the gyroscope calibration because the calibration of the gyroscope is already performed inside the sensor fusion algorithm. So we will proceed by starting from the accelerometer calibration and then integrate inside the code for the sensor fusion. So if we enter the example here, you can see that it has a README, an output folder with pre-built files, and then an ISPU folder containing all the development files. So this is what we need for our purpose. So we will go ahead and copy this folder right here, and we will rename it in inclinometer. Perfect. At this point, we can open the Cube IDE. Okay, and from here, we can import the new project. So we go on to General, Existing Projects, and we browse to our folder. Inclinometer, and then we select the Eclipse folder. Click on Finish, and the project is correctly imported. At this point, we can also rename the project. Now we rename it into ISPU inclinometer, like so. Perfect. So now the first step is to get the needed libraries. So if we go back to the folder here, we can see that in the lib folder we just have the accelerometer calibration library, but we also need the sensor fusion. So we go back to the S-Cube ISPU package, navigate to the sensor fusion example, to the ISPU and lib folder, and from here we can copy the files for the library. Then if we go back to the Cube IDE, here we have to go into the properties of the project, under build, settings, and libraries here. And so we have to add the motion effects to be linked. Alright, now we can actually modify the code, and we'll go ahead and import also the sensor fusion example so that we can copy the code from there. So we'll navigate to the example and to the Eclipse folder. Alright, so now that's also imported. I will open the two main files side by side, like so. Alright, and we can start integrating. So first of all, we need to include the motion effects. Then we need also the sensitivity value for the gyroscope data. Then in terms of global variables, you can see that the time variable is in common, but we need to copy instead this pointer to the motion effects instance. Then we have the initialization function to initialize the two libraries. So here, first of all, you can see that the time for the device is computed based on the device register. And for this, you can find more information on the application note. But the idea is that you get always the value referred to 104 Hz. In this example, we will run our algorithms at 52 Hz. So that's why you have to scale by 2 our time. Then here it was scaled by 2000 in order to get the value in milliseconds, but I will modify to get it in seconds. Alright, so then we have just to modify here the init code for the accelerometer calibration to scale the time accordingly to milliseconds again for this library, while for the motion effects we will use directly in seconds. Then we can copy the code to initialize also the motion effects correctly, like so. Very good. Now we can move to the run function where we actually run the algorithms. Here we need to copy first of all the variables that we need for the motion effects. Then again we have a time for the accelerometer calibration to scale, like so. Then we can copy the code to run the motion effects. Okay, in this case though, we do not want to take the raw accelerometer data, but we want to copy the code to compute the calibrated accelerometer values, like so. So in this way, the sensor fusion will use calibrated accelerometer data, and then the gyroscope will be calibrated internally. As a last step, in terms of outputs, we do not want all of this, but we want the same output of the sensor fusion example, which are the quaternion values that represent the orientation of the device in the space, and then we will also keep the calibration quality. Alright, then there is one last step that we have to do from here. So you can see that there is this configuration file. If we now open it, it contains the sensor configuration and the ISPU configuration. So all the settings are ready as we want, but we need also to configure the gyroscope sensor. So we will also configure it to 52 Hz, then the full scale to 2000 dps, and the power mode to high performance. Perfect. So now we can actually build our project. So you can see that it's compiling everything. At the end, it will produce a UCF file containing the final configuration. If we go to our folder here, going to Eclipse and release, we have the UCF file generated. The UCF file contains all the right operations to perform on the device interface in order to load the sensor configuration and the ISPU program. Now, if we want to test our new example and visualize the results, we can use AlgoBuilder and UniQloGUI, which I have already installed. But first, we need another file. We need the JSON file, which describes the output of our algorithm. So we'll go ahead and copy the JSON file from the output folder of the sensor fusion. We copy it in the same folder of the UCF and rename it with the same name so that the tools can automatically find it. If we open this file, we can see that it describes the 4 quaternion values. In our case, though, as you may remember, we also have the calibration quality. So we have to add that. So we can go and copy from the accelerometer calibration example, and we copy the last value, like so. Now we are ready to build the visualization part. So let's go ahead and open Argo Builder. Alright, from here the first step is to create a new design. Browse to choose the location where the firmware will be generated, like so. And then here we need on the target to select our hardware configuration, like so. Then let's also go ahead and save this design file for Argo Builder. I will call it Inclinometer. Alright, and we are set. So first of all, here on the sensor hub block, let's set up all the configuration in the same way as we did for our sensor, like so. Then we have to add the ISPU block connected to the sensor hub. What this block does is that it lets us load the UCF file. So then we go ahead and find it into our project, and there it is. So then what we want to do is to visualize it with the fusion block, which will use a 3D model. But you can see that it takes an array of 4 floats as an input, so we'll need also a max float block here in the middle, which we can configure for 4 values, and then we can use it to input the 4 values of our quaternion, like so. Alright, very good. And then if you want also to visualize the status of the calibration, we can, for example, add a graph, which we will configure with just one value, like so. We can give it a name of hcal, and then we'll give the waveform the status name. Then let's just add autoscale on. Then we can very simply connect the two like this. Very good. Then we can build the project. This will generate automatically a firmware based on the flow that we created here, and it will build it with the cube ID. Okay, as you can see, finished the build. So now we can go here and program the Nucleo board. Board is flashed, so now we can click here to run uNucleo. Alright, so you can see here that we have H calibration and sensor fusion. We can click on start. If we go to H calibration, you can see that the value at the moment is 0 because it's not calibrated. Now I will move for a few seconds the device on all the 6 phases in order to collect all the points needed to perform the accelerometer calibration. So you can see that now went to 3, which means that it's calibrated with a high accuracy. So we can close this and open instead the sensor fusion tab. So here, if I put flat on the table the device, you can see that the 3D model is flat, and then I can tilt it on one axis or on the other axis, and everything is extracted with accuracy.